The purpose of our Lab 6.1 is to use decimal squares as a visual model for the part-to-whole concept of decimals and for illustrating decimal equality, place value, and estimation. The manipulatives that we will use today will be our decimal squares. So if you'll get those out now, we will use them to meet our goal. We're going to let one square represent a unit. So if I look at the shaded and the unshaded combined, that would represent 1 for all of these. The red represents tenths. So you have 1, 2, 3, 4, 5, 6, 7, 8 tenths. This represents hundredths. And so you would have 30 hundredths. And then these represent thousandths. And so I try to find where the column would be of tenths, and I would have 1 tenth, 2 tenths, 3 tenths, 4 tenths, and 5 tenths. But actually what I have is 500 thousandths, because each tenth would have 10 thousandths. So when I look at this square, it models 1 tenth, but it also models, it models 100th, and that also models 10 thousandths. So 100th is 10 thousandths. Now if I look at the column that represents 1 tenth, there would be 100 thousandths that represents 1 tenth. So the usefulness of these is that we are able to compare. So if I want to compare 8 tenths to 500 thousandths, I can see that 8 tenths is greater than 500 thousandths. Or if I want to compare 30 hundredths to 8 tenths, I can see that 8 tenths would be greater, and hence goes back to the rule that you always look at tenths place, and the number that has the greater tenths place would be the greater value. Students often think that the longer the number is, the greater that it is, and so we have to be sure to model plenty examples where they see that tenth is greater than 100th, and that then is greater than 1,000th. So let's find the 10th square. So here we're modeling 1 tenth, and now let's find the 100th square. Well, I'm not having much luck finding the 100th square. So I'm going to take this and hide part of it. So I have 1/10 compared to 100. So we're able to see that it would take 10 hundredths in order to make 1/10. And then if I get 1,000th, which again, I'm not having much luck finding the 1,000th, so I'm going to hide part of the square so that we're looking at 1/10 compared to 100th compared to 1,000th, the very tiny little square. And so we can see that it takes 10 thousandths to be equal to 100th. And it would take 10 hundredths to be equal to 1/10. And it would take 100 thousandths to be equal to 1/10. All right, let's say that we want to compare or put in order these decimals. 3/10, 35 hundredths, and 375 thousandths. If I want to order those according to size, you know that the rule says that if you are comparing, always compare tens place. Well, in this case, tens place is the same. And if let's see, find your 3/10. Well, I can't find it, so I'm going to use 4/10. All right, find your 4/10. And find 45 hundredths. So you can see that by comparing these two, it takes 40 hundredths to be 4/10, and then you have 5 hundredths more. So if I want to compare these, I would say that 4/10 is less than 45 hundredths. Now let's see if we can find 375 thousandths. So we have 375 thousandths. Now when I compare that to 4/10, I can see that that is smaller. So I would have to say 4/10 is greater than 375 thousandths. And if I compare that to 45 hundredths, you can see that it also is smaller than 45 hundredths. So if I want to compare them, even though this one has more digits, if I look at tens place, the 3 is the smallest of the 3 decimal numbers. Therefore, 375 thousandths would be the least, and then 4 tenths, and then 45 hundredths would be the greatest. It's a good idea to put zeros in front of the decimals. It's not required, but it helps us understand that there is no number in ones place, and we're only dealing with decimal values. I like using graph paper to help illustrate hundredths and tenths and thousandths, and you can download on the internet graph paper that is marked in tenths, hundredths, and thousandths. And so in this problem, you are asked to shade 4 tenths of the total. And so you would know to shade in 4 of the bars. Here you're asked to shade 75 hundredths. And so you're going to shade 7 full bars and then half of the next bar. Here you want to shade 325 thousandths. So you're going to shade 3 tenths, which is 2 full bars. You're going to shade 2 hundredths, which would be this square and this square, and then 5 thousandths would be 5 of these little bars. Now if we want to compare them, even though 325 thousandths has more digits, it's the smallest of the 3 because tens place is smallest, and then 4 tenths and then 75 hundredths would be the greatest. Now, sometimes we want to look at regions that are shaded, and we want to determine what fraction or what decimal of those are shaded. Now I know that there are 100 squares that make the total, and so I have 10, 18, 24, 32, so I have 32 hundredths. In C, sometimes it's easier to count the part that is not shaded and subtract from 100, because I know this is a 4 by 4 square, so there are 16 squares away from 100, means there are 84 that are shaded. Therefore, 84% would be shaded. Also, in writing decimals, if you are asked to show 9 shaded parts out of 10, that's representing the number 9 tenths. Or 13 shaded parts out of 100 would be representing the decimal 13 hundredths. Now there's a game that you can have your students play, and it takes 2 people to play the game, but I will set up the game so you can see how the game is played, and it helps the students in understanding which decimal value is greater. So you take your decimal squares and you deal out all the decimal squares and then turn them over. So you have two people with all the decimal squares dealt out. So player 1 turns over his card, player 2 turns over his card, and the card that is greater wins both cards. So the students compare and they see that they are very similar. You have 100, 200, 300, 400, 500, 600, 700, 725 thousandths. This one is 700, 1, 2, 3, 4, 5, 700, or 10, 20, 30, 40, 50, 750 thousandths. This one is 725 thousandths. Therefore, this person wins and they win that hand. And they continue doing this, comparing until there is a winner or until time runs out. And so that gives the students practice in comparing and working with place value. Also, they might run into a tie because a situation might arise where they have 4 tenths, 40 hundredths, and 400 thousandths that are equivalent. And so that is also a good situation to have happen where they have to decide, well, there's a tie, so what do we do now? For your assignment, and you can use graph paper, which can be printed free online, or you can use the decimal cards and take a picture. But I want you to compare using is greater than, or is less than, to answer these questions. You are comparing these numbers. So that's what you should attach into Blackboard for this lab.